Welcome. My name is Marcos Albe. I'm a principal support engineer at Percona, and we'll be talking about how to pick MySQL high availability solution. Okay, next. Here's our agenda. I'll briefly describe what we understand as availability, what components are required to build a solution, what options we have for these components, and what do we choose from among those options at Percona. So availability, we define it as the capability of delivering a service in an uninterrupted fashion, providing the necessary consistency and within expected response times. Some databases obey to another paradigm where they value availability over consistency, but we expect MySQL to be consistent, so it's part of our definition of HA. So uptime. Uptime is a synonym for availability, basically, right? If we are down, if it's down, then it's not available. And here we can see the famous percentiles we see advertised everywhere for uptime. And the industry standard measures these percentages over a year, so we can tell how much downtime each percentile represents. So 99%, it's 3.60 days, and 5 nines, it's only 5.25 minutes. And that's what you promise your boss, you're going to be down, okay? And here are some estimates for each method. So it's a bit wild how much they can vary, but it's a fairly good representation of what you can expect for planned downtime. This is not for unplanned downtime. Okay. So what do we need to build an HA solution? There are 4 basic things you need. You need to have some form of redundancy for the data, and possibly also for the different pieces of the infrastructure. You need to have durable writes. You need to have clustering tooling for monitoring, failover, routing. And you need to have low latency. Like, performance is important for HA. So again, HA is redundancy. HA redundancy, to achieve high items, you need to have some form of redundancy for the data, usually in the form of replication. This is the most important bit when you're thinking about your HA solution, as it provides or not the features necessary to avoid unplanned downtime and the resilience to failures and accidents of all sorts. And it will dictate for all other pieces, it will dictate restrictions for all other pieces of this puzzle. The fact is, we don't want a single point of failure that will put you down at any time that piece fails. And we know that infrastructure failures are a fact of life. So we must build redundant infrastructure to achieve high availability. For durable writes, you must have a write with mirroring. For redundancy, you possibly want multiple nodes in multiple data centers. And your failover mechanism must not be centralized in a single node either. So it's not only your database, but also the things that drive you into your database that also must be redundant. And well, your application nodes should also be redundant. And also, if you can afford redundant hardware, like power supplies, network cards, and whatever else, within the single node, that will also increase uptimes by avoiding unplanned failovers in the first place. Then durability. This is the D in ACID. And it's a strong requirement for availability, because knowing the writes are on disk on the other side, and that they arrived in the right order, is necessary for us to say, okay, this failed, okay, I know my writes are on the other side, and I can go there safely without losing data. And finally, clustering. This is not like NDB cluster or Galera cluster. Again, this is the tooling to route the queries and the clients into the database. So it's like load balancers, proxies. And as we said, you need to have some mechanism to direct client traffic to available resources, because these tools will monitor health and direct the queries to other available nodes if the node a client is using has failed, or if we're performing a planned failover. Some proxies and load balancers also allow setting more complex rules for how to direct to the nodes. So they are not only for failover, but also for traffic shaping. We'll see a bit of that. Tell me if I'm going too fast. This was a 50 minutes talk, and I cut it down. I only have rehearsed it once, so apologies for that. If I'm going too fast, I can slow down. OK, performance. So this might seem a bit strange, but yeah, good performance is necessary, or at least very, very desirable, because for becoming highly available, because all very necessary for becoming highly available, because all HA solutions imply some overhead. There's no way that there will be no overhead. Some is more, some is less, but there's always overhead. And if the overhead is too much, then you will fail to comply with your internal SLAs. And also having unacceptable response times is in some way a form of unavailability. And its example is an ATM where the transaction times out because the database was too slow to respond. So we were able to communicate with the database, but it didn't give us the response on time. So the customer never got his money, and it failed. So the service was not available for him in the end, even when the database was. So to cope with the overhead, we need to achieve a good base performance, which requires well-written queries, good schema design with appropriate indexing, proper understanding of configuration trade-offs, reasonable hardware and speed links for replication setup. Unfortunately, time won't allow me to deep dive into this, but it's important that you keep in mind that performance is also part of the design in an HA solution. And HA for databases is particularly harder than for other components because data is changing constantly. And most of the times, again, we want a consistent database on the other side. And your database is possibly changing more than anything else in your setup. Like, I don't know, your Apache configuration doesn't change. Your code doesn't change so often. And other than the images your user uploads or the user, I don't know, other files your users might upload, files in your servers don't change as much. But the database, possibly 50,000 times per second, you know? So when there's a crash, we have to figure out how much of the last second is on the other side to be able to fail over with peace of mind that we will go into a consistent database. OK, now we will visit the possible solutions from least recommended to most recommended. And so redundancy through XA, simply don't do this. So XA transactions, you have a transaction coordinator that you give it to databases, and you say, OK, I wrote to this database, I wrote to this database, now I want to commit. You send the commit, and both nodes have to reply, OK, I was able to commit. And so then the XA transaction coordinator finally does a second phase commit, and those writes become durable. This is prone to so many failures that just don't do it, especially with MySQL. Then redundancy through sharded storage, a SAN. So the price of the SAN is like a high barrier already. And if you want to have redundant SANs, then it's like a doubly high barrier. And it's complex to operate. And you could have multiple SANs and stuff like ScaleDB or RAC or Oracle RAC. But vast majority of the people will have only one, and that will be a single point of failure. And on top of that, failover, it's a cold failover. You have to unmount the disk from the failed instance if the instance is still up. You have to stop the MySQL on the old instance if MySQL is still up. And then only then you can mount the drive on the other side and bring up MySQL on the other side, which will have a cold buffer pool. So horrible. This is not for uptime. Then DRBD. This was good. Like a few years ago, this was a good option because it was the only way we could tell with certainty the writes are on the other side and are durable and they are flushed to disk. So, but with the advent of semi-sync, lossless semi-sync replication, and later with Clara cluster and now group replication, it has fallen into disgrace due mainly to two facts. One is that the second node is not usable. So you have something in your rack that is there just getting bytes from the main server and just waiting for you to use it someday. But you cannot put read traffic like you will do on a regular MySQL replica. So there's a cost added to this. And there's also a high latency impact, because usually we will expect a write to take 1 millisecond or less, but there are no 1 millisecond network round trips all the time. It can really have 4 milliseconds. That is 400% more. So it can really have a large impact on your performance. And you will always have at least, 20, 30% performance degradation. There's no way that the network is going to be as fast as a local disk write. Finally, these are the replications options we all know and love. And we'll visit the first two and briefly touch on tungsten. And unless we have someone from a telco, anyone? OK, then we will skip NDB cluster. It's costly, it's complex, and the real use it has, it's for telcos, which is what it was designed for. And I never saw another good use case for it, at least. So replication. I could speak 4 hours about this. If you have questions, I will be outside. You can ask me anything you want. But at the high level, initially it used to be statement-based. This was years ago. And in 5.1, we got row-based replication, which is safer, but has a few trade-offs. Like if you update 1 million rows, then you will write 1 million events into the bin log instead of a single query. So your bin logs just exploded. And it also had to copy all those events to the other nodes. So your network also exploded. And also, there are some bugs that affect performance until this very day. But you only will hit those if you don't have primary keys and expect everyone to have a primary key. So still, even with row-based replication, it was not enough for lossless failovers because it used to be asynchronous. This means the master accepted writes, and it was never aware if those writes made it to the slave or not. The slaves could have nothing from all the writes the master got. So it's asynchronous. In 5.5, we got semi-sync replication. And in semi-sync replication, a commit basically waits until the transaction has been replicated to the relay log. It's not yet applied on the slave, but it lives on the slave's relay log, and it's flushed to disk. Actually, the full guarantee of this is only available since 5.7, with lossless semi-sync replication. And I will quote Yoshinori from Facebook and Tina. The objective of semi-synchronous replication is simple. Master failover without data loss, without full durability, which is particular because we could disable durability knowing that the other guy has it, which it's more or less like that, but you can reduce durability and have the things on the other side with a high degree of certainty. This choice along MHA or orchestrator is a really solid solution that is delivered in very large deployments, and it works. It simply works. But you have to keep in mind that the writes are affected by latency due to the need to wait for the network round trip and to flash the write to the disk on the remote node. So depending on your workload, this might or might not suit you. But for sure, it does scale, and it's very, very reliable. And do read that blog post. It's like it really clarifies the picture of all this much better than what the time allows me right now. But basically, they deployed that at Facebook, and it works. The slides are going to be available at the website later. Well, Galera cluster. Galera has been around for many years. I believe Percona sort of helped it, popularize it through ExtraDB cluster, which I'll call PXC for short. It replaces the regular MySQL replication. It does use a lot of the infrastructure for MySQL replication, but it doesn't need you to produce bin logs. So it could save you from a lot of writes. But a PXC node, even when it's not an asynchronous node, it can act as a master or a slave or both in a asynchronous replication setup. So you could have a cluster and then have an asynchronous node, and it could be the master or the slave of the cluster. Galera, it's also called virtually synchronous solution, where the writes are sent to all nodes and certified by every node to be free of conflicts in a synchronous way, but then applied to the replicated nodes in an asynchronous way. So the synchronous part is knowing that the writes we performed are not in conflict with any other transaction that is in flight in the other nodes or that is being committed in the other nodes. That is the synchronous part. And that the write is durable on the other node as well, like semi-sync. The other parts are not synchronous, are asynchronous. Applying the events is still asynchronous. There could be a small delay, but there are options in the configuration that allow you fully synchronous read, updates, and deletes. 1 minute? Oh my God. I've only been here 15 minutes. But that stroked me a bit. I counted with 10 more minutes. So the minimum number of nodes we recommend for a cluster, a Galera cluster, is 3 nodes, which also adds an extra cost you have to consider. The cluster is elastic, meaning that the nodes can join and leave the cluster without operations being interrupted, and that the cluster will self-heal in case a node or more nodes crash. But there are situations where multiple node crashes could cause loss of quorum and put the cluster in a non-available state. Again, this is unplanned downtime. There are some configurations options to cope with this as well, but it's not possible to avoid 100% of the cases. So monitoring is probably your best tool for this. Another thing to keep in mind when considering Galera-based cluster is that the slowest node on the cluster will drive the performance of the whole cluster, because writes will have to be certified there as well. So if a node starts swapping, for example, it could slow down all the other nodes in the cluster. Also important to know is that these clusters are not intended for scaling out writes. They are intended to scale out reads. So the purpose here is high availability, no brainer failover thanks to the write anywhere capability, and reads scale out. Then group replication is very much like Galera. It's a bit younger. It lacks some features, has some other features which are cool, like flow control is better in group replication, but it doesn't have automatic node provisioning. There are some comparisons, like Vadim, our CTO, did one, and Frederic, which is the evangelist, he's chief evangelist for, or MySQL evangelist for Oracle. He also wrote another comparison between both, worth reading them. Again, you can extract the links later from the slides. Well, Tungsten, it's an external replication that uses MySQL bin logs, but it then streams its own protocol. And this allows you to do a lot of advanced things. The coolest of them all is to migrate from Oracle without having to pay them a license, which you will have to pay Golden Gate or something like that. So this is basically free Golden Gate. I don't know how many of you know the technology, but it's basically Oracle's replication mechanism. And while it does, this works fantastic, and it's stable, but it's an extra piece in the stack, and it's dual licensed. So the community version is free, but the enterprise version has a license. So we recommend it when it's appropriate and there are no other solutions. OK. So, oops. Handling failure. So failure and software are a fact of life, so we must be ready. The first thing is how to detect it, which can be done via polling, via alerts, or errors returned to a handler that knows what to do. And then when we found a problem, what do? Well, we point traffic to the next appropriate node, where appropriate means that it has applied all the transactions that had run on the now failing node. This might not always be possible, but it's what we would like. And MHA does a good job to try to apply missing events by copying bin logs from the failed master if the failed master is still physically up, if it's still accessible through the network. Also, while handling failure, we must make sure to preserve integrity by avoiding having more than one master. So like in the case of a master that at some point became unavailable through the network, it became network partitioned, it suddenly comes up, and applications start connecting to it, you will have a split brain. And you don't want that. So what we do is we stone it. We shoot the other node in the head. Literally, we fence it and don't allow anything to go into there. So that is to prevent having two masters at any point in time. And, well, see, if you have PXE, you don't need to do this. Failover is transparent in that case. Tooling to handle failure, there are a large selection of them. We will go over Orchestrator and MySQL MHA. Orchestrator was developed by Shlomi Noak during his work at Outbrain, Booking, and GitHub. It's maintained and is doing automated failovers at many large setups. It works by polling the servers. It maintains the state of all your topology, so it can take very well-informed decisions. And it takes smart decisions on which node to promote, not only based on the most advanced, but it also makes considerations like, is this the same version? So if my main master is 5.6, I don't want to promote a 5.7 node. And many times, you have a 5.7 because you are upgrading other nodes, or you are testing 5.7 or whatever, and so you have 5.7 slaves. You don't want to promote those because they're going to break all your replication. So what this guy does is it checks configuration, versions, and then says, OK, this is good. This is going to make the least amount of nodes to fail when I promote it. And also, it not only does failover, but also allows you to manage your topology and to move slaves, like to repoint a slave to other masters. And you can actually do this by drag and drop. So it's really nifty. You can also do it through a API or a like a command line user interface. Well, I had so much more. My slides have all the nodes, so you will be able to enjoy the nodes that I am not able to read right now. But I want to at least go through all of them. Oh, sorry, I had the blank. Apologies for that. Again, there are good links for like in-depth reviews of Orchestrator there. And MHA was, and Orchestrator is now our de facto recommendation for failover.
So we have a setup where we have circular replication, right? And
Stop doing it.
So Orchestrator was showing it all till that circular thing came in, and the minute the circular replication was set up, the Orchestrator broke. I mean, it doesn't show me any graph.
I don't think it was meant to be used with circular replication. I will need to see logs and whatnot and the state of the slaves to actually give you a diagnostic. I never heard of the case before, but it's unlikely used along with circular replication. And seriously, don't do that to yourself. It's going to hurt.
So there is one rare scenario where we had to hit that.
OK, guys, unfortunately, I'm all out of time. And I still have like a few more slides. Who's the next presenter? Can I take 4 more? No?
Mine's going to take 35 minutes.
Oh, you're 35? How did you go 35? I only got 25. I actually only get 22. OK. Just for completeness, it's very quick. Then these were tools for failover. Then we have tools for multi-master clusters, which are meant not to failover, because multi-master clusters don't need to failover. They just need to route traffic appropriately. Like if a node goes south, we don't want to send any more queries there. We want them to be routed to other. And for load balancing as well. So there are a large selection, well, a not so long selection. Our recommendation is Proxy SQL. It really can do a lot of magic. It's very stable. It scales very well. And it's being actively developed. And it's, again, our de facto recommendation. So conclusions. Simple is better. MySQL replication is better than DRBD and SAN. Asynchronous replication is good for one because it's not bound to latency, but you're bound to possibly lose data on the other side. Lossless semi-sync replication is very little risk of data loss, but it's latency bound. And multi-master has no failover required. It's latency bound. So there are trade-offs. There are always trade-offs. There is no way to have a golden solution. You have to pick what fits your workload, your data centers, and your hardware, and your business requirements. And finally, MySQL replication is amazing if you know it and monitor it. Monitoring is your friend. And large sites run very good with semi-sync and tooling for clustering. And Galera cluster is very well tested, and it's a great choice for virtually synchronous replication. I hope you enjoyed it, and I apologize for the rush. I will be available outside for any questions you guys might want to do.